A massive object is carving through our solar system, and it's behaving in ways that shatter every rule we thought we knew. Scientists called it 3I Atlas, dismissing it as just another wandering comet from deep space. But the James Webb Space Telescope just captured something that's igniting panic across observatories worldwide. This visitor from beyond our sun isn't following the laws of physics that govern every other object we've ever studied. What researchers initially brushed aside as unusual is now impossible to ignore. The trajectory alone defies astronomical probability. This thing is moving through space with a precision that seems calculated, engineered even. And buried in the data is a connection to one of humanity's most haunting mysteries, a signal we received decades ago that we never fully understood. The evidence mounting around 3I Atlas suggests we're not dealing with a random chunk of ice and rock. We're looking at something that challenges our fundamental understanding of what travels between the stars. And as it races toward the inner solar system right now, we might be running out of time to figure out what we're really dealing with. The $10 billion James Webb Space Telescope was built to peer into the darkest corners of the universe, capturing light from galaxies that formed when time itself was young. But recently, Webb turned its unprecedented power toward something far closer, an object drifting through our own stellar neighborhood. The images it transmitted back didn't just puzzle scientists. They threatened to overturn centuries of astronomical understanding. Atlas marks the third interstellar visitor humanity has detected entering our solar system. When astronomers first spotted it, they quickly classified it as a comet, another icy wanderer expelled from some distant star system. Standard procedure, routine observation, nothing to warrant alarm. Except a small group of researchers noticed details that didn't align with that comfortable explanation. Details they discussed only in hushed conversations, afraid to voice suspicions that seemed too radical, too extraordinary. Now, Webb has delivered the proof they needed. The data confirms what these scientists privately suspected but dared not say too loudly. 3I Atlas is something far stranger than any comet we've encountered. The first warning sign emerged from measurements of its physical dimensions. Early estimates had already suggested something unusually large, but Webb's high-resolution infrared imaging refined those numbers into something truly staggering. The diameter of 3I Atlas exceeds 3 miles, translating to a minimum mass of 72 trillion pounds. This object is a titan. Consider the scale here. Oumuamua, that first interstellar visitor that captivated the world, measured roughly the size of a football field. The second visitor was even smaller. Now we're tracking something thousands, potentially millions of times more massive. The statistical improbability screams at us. Why would the third object we detect be a giant while the first two were mere pebbles? Imagine standing at the shore of an ocean, spotting 2 tiny minnows swimming past, and then immediately seeing a blue whale surface right beside you. The natural distribution of objects doesn't work that way. Something fundamental doesn't add up about 3I Atlas appearing in our detection window at this size. It's as wide as Manhattan Island, a floating metropolis from an origin we cannot trace. But the sheer enormity was only the beginning of the mystery. What Webb captured next, in crystalline detail through its infrared cameras, was the feature that truly demolished conventional explanations. Every astronomer learns the basic behavior of comets. As they approach the sun's heat, surface ice sublimates into gas, creating the characteristic glowing tail. That tail always points away from the sun, pushed by solar radiation and the solar wind. It's one of the fundamental, unbreakable rules of cometary physics, observed across thousands of objects throughout recorded history. Atlas violates that rule completely. Webb's imagery reveals a bizarrely structured, highly collimated jet stretching 10 times longer than it is wide, and it points directly toward the sun. Picture smoke from a bonfire blowing straight into gale-force wind. It defies basic physics for a passive, natural object. The energy required to maintain such a powerful, tightly focused stream against the sun's immense outward pressure is extraordinary. No conventional model of cometary outgassing can explain this phenomenon. What makes it even more perplexing is that a normal cometary tail only began appearing faintly in late August of this year, almost as an afterthought to the primary feature. The forward-facing jet remains the dominant characteristic, a massive, luminous column aimed like a weapon at our star. This wasn't a minor oddity that could be explained away with creative astrophysics. This was a blatant contradiction of celestial mechanics. Scientists worldwide are desperately working to construct explanations, but every natural model fails under scrutiny. Could some unknown chemical reaction be responsible? Some exotic form of ice with properties we've never documented? Or is the terrifying alternative true, that the jet isn't really a jet at all, but rather controlled emission, a form of propulsion? That concept has lived in science fiction for generations. But now, we're watching it play out in real time through humanity's most sophisticated telescope. 3i Atlas isn't passively tumbling through the void. It's actively, deliberately interacting with our sun in a manner never before witnessed. And that active behavior was just the surface of what Webb would reveal. The chemical analysis would prove even more disturbing than the physical observations after documenting the impossible jet and Manhattan-sized mass. Scientists deployed Webb's advanced spectrographic instruments to analyze the fundamental composition of 3i Atlas, examining the gas and particles streaming from its surface. Standard procedure for any comet involves identifying a very specific chemical signature, one dominated by water ice, carbon dioxide, methane, and other common volatiles. This cosmic recipe remains remarkably consistent across every comet in our solar system. It's the fingerprint of natural formation in the cold outer reaches where these objects are born. What Webb detected in the plume surrounding 3i Atlas wasn't just a different recipe. It was a composition that looks disturbingly artificial, like something designed in a laboratory rather than formed by natural processes. The first alarm came from the nickel readings. The spectrographic data showed nickel concentrations far exceeding iron levels in the outgassing material. In natural cosmic chemistry, iron vastly outweighs nickel. It's a fundamental consequence of how elements are forged in stellar furnaces across billions of years. Finding excess nickel is extraordinarily rare in natural objects. On Earth, we primarily encounter high nickel concentrations in one specific context: industrial alloys. High-nickel steel is engineered by humans for extreme applications requiring exceptional strength, corrosion resistance, and high-temperature tolerance. It's critical in advanced aerospace manufacturing and cutting-edge industrial processes. Discovering this chemical signature in a supposed comet is absurd. It's equivalent to analyzing volcanic ash and finding it composed primarily of refined jet fuel. But the chemical impossibilities didn't end with nickel. The second profound anomaly involved what was missing rather than what was present. The plume around 3i Atlas contains almost no water. Instead, it's dominated by carbon dioxide. For every comet ever studied in our solar system, water is the star performer. It's the primary volatile that drives cometary activity, creating the spectacular displays we observe. A comet without significant water content is like discovering an ocean without salt, fundamentally contradicting what we understand about these objects. This composition suggests 3i Atlas formed in a region of its home star system that was bizarrely, inexplicably dry. Astrophysicists struggle to model conditions that would produce such a result naturally. Or it suggests something far more unsettling, that 3i Atlas isn't a comet at all. The combination of industrial-grade metal signatures with a completely unnatural volatile composition paints an increasingly clear picture. This isn't an object shaped by random collisions and natural accretion in a protoplanetary disk. The evidence points toward something constructed, something manufactured with purpose. As if the physical and chemical impossibilities weren't enough, 3i Atlas added another layer of strangeness in how it interacts with light itself. When sunlight reflects off an object's surface, it becomes polarized. By measuring this polarization, scientists can determine surface texture, composition, and structure. Every major object in our solar system, from asteroids to comets to planets, polarizes light in a predictable positive pattern. We've measured thousands of objects, and this behavior remains consistent. I, an atlas, displays extreme negative polarization. This incredibly rare phenomenon indicates a surface composed of exceptionally fine, porous, complex materials. The structure resembles an intricate network of microscopic formations, unlike anything we typically see in natural space objects. This isn't a minor deviation from the norm. It represents a fundamental difference in how 3I Atlas interacts with electromagnetic radiation, setting it apart from 99.9% of known celestial bodies. Every new piece of evidence was stacking up, painting an increasingly disturbing picture. But the most chilling revelation was still to come, hidden in the mathematics of its trajectory through space. Beyond all the physical properties, the path 3I Atlas is traveling through our solar system may constitute the most compelling and terrifying evidence of all. When an object gets randomly ejected from another star system, its trajectory should be essentially random. It could arrive from any direction, at any angle relative to our solar system's orientation. The odds of any particular alignment are astronomically small. The trajectory of 3I Atlas is anything but random. It exhibits a level of precision that resembles careful navigation more than cosmic chance. These are facts encoded in orbital mechanics, immutable mathematical truths that cannot be dismissed or reinterpreted. Unlike its composition, which we study through observation, its trajectory is pure calculation, and those calculations reveal impossibilities. First, there's the ecliptic alignment. The ecliptic plane is the flat disk where all our solar system's planets orbit the Sun. For a random visitor from interstellar space, the probability of its path aligning closely with this plane is vanishingly small. Space is three-dimensional. Objects can come from any angle. Yet 3I Atlas's trajectory aligns to within 5 degrees of the ecliptic. The statistical likelihood of this occurring by pure chance calculates to just 0.2%. Imagine throwing a dart from a mile away in complete darkness, and not only hitting the correct building, but striking the precise floor where everyone has gathered. That's the level of improbability we're discussing. Astronomers immediately questioned whether this alignment could possibly be coincidental. Then, the trajectory gets even more suspicious. The timing of 3I Atlas's arrival appears optimized to an unbelievable degree. As it swings around the Sun, its path brings it remarkably close to several key planets. It's executing what resembles a grand tour of our inner solar system, with close approaches to Mars, Venus, and even distant Jupiter, calculating the probability that a random, interstellar object would arrive with timing that allows for this series of planetary encounters yields a result of 0.005%. This isn't simply passing through our neighborhood. It's conducting a series of close approaches that would be ideal for deploying smaller probes or gathering comprehensive reconnaissance data. It's precisely the trajectory an advanced civilization would engineer for a systematic survey mission. But the final piece of evidence is what truly sends chills through anyone who understands its implications. It connects 3I Atlas to one of astronomy's most profound unsolved mysteries. On August 15, 1977, the Big Ear radio telescope in Ohio detected something extraordinary. A powerful 72-second narrowband radio signal emanated from deep space. The signal was so unusual, so precisely what scientists expected from an artificial extraterrestrial transmission, that astronomer Jerry Amon circled it on the computer printout and wrote a single word: "Wow." It became known as the WOW signal, the most promising candidate for extraterrestrial communication ever recorded. Despite decades of searching, it never repeated. The origin remained one of astronomy's greatest enigmas. Now, incredibly, the arrival direction of 3I Atlas aligns to within 9 degrees of the WOW signal's origin point. The probability of this alignment occurring by random chance is just 0.6%. Could this massive object be the long-awaited follow-up to that mysterious 48-year-old transmission? Is 3I Atlas the physical message arriving decades after the initial announcement? All these statistical impossibilities converge on one inescapable question. What is the true purpose of this object, and what happens when it completes its approach? 3I Atlas is currently barreling toward its closest approach to the Sun on October 29th of this year. As that date approaches, the scientific community and increasingly the wider world watches with a mixture of fascination and dread. The mountain of evidence, from its city-sized dimensions and physics-defying jet to its industrial chemical composition and impossibly precise trajectory, has shifted the conversation entirely. We're no longer asking if this is an unusual comet. We're asking what its true purpose is. Those following this unfolding mystery are right to sense something profound is happening. We may be witnessing one of the most significant events in human history, and we need to consider every possibility. No matter how uncomfortable, is this merely a string of unbelievable coincidences, a one-in-billions natural fluke? Or are we collectively avoiding the obvious truth because confronting it means accepting that our place in the universe is far different than we believed? One theory gaining traction with each new data point is the Trojan horse scenario. In ancient mythology, an innocent-looking gift concealed a deadly threat. In this cosmic version, an object masquerading as a natural comet could be something far more sophisticated. It could be an interstellar probe designed to comprehensively study our solar system. The close flybys of Mars, Venus, and Jupiter could represent intentional waypoints for releasing smaller survey craft. These devices could use planetary gravity assists to redirect toward Earth or other targets of interest. Given 3I Atlas's retrograde orbit moving opposite to planetary motion, releasing probes during these encounters would efficiently enable surveillance of the entire solar system. This isn't baseless speculation born from science fiction. It's a hypothesis that disturbingly fits every known fact. The philosopher Blaise Pascal argued it's logical to consider unlikely possibilities when their implications are infinite. Even if the probability is small, the consequences demand we take it seriously. The same reasoning applies here. The technological origin of 3I Atlas might represent a low-probability event, but its implications would fundamentally alter everything about our species and our future. In the coming days and weeks, we may finally get real answers. Between October 1st and 7th of this year, as 3I Atlas makes its nearest approach to Mars, a fleet of orbital spacecraft from NASA and the European Space Agency will turn their instruments toward this visitor. The high-rise camera on the Mars Reconnaissance Orbiter will capture images with a spatial resolution of just 19 meters per pixel, a view 20 times sharper than Hubble can achieve from Earth orbit. These images could reveal 3I Atlas's true shape and surface characteristics. Is it a uniform rocky body, or does it possess structure, geometry, perhaps even artificial features? The orbiters will deploy their spectrographs to obtain new close-range readings of its composition. Will the unnatural chemical signatures persist under this intense scrutiny? We're about to get our clearest look yet at this enigma. The idea that nature could be more imaginative and stranger than anything